Hello and welcome back to the channel. My name is Eddie Jennings from EJSLLC.com. This is going to be the first of several videos dedicated to the rebuild of my home lab. And the idea behind these videos is as I build and deploy something for the lab, I'm going to make a video showing the steps of how I do it, in hopes that if you're wanting to do these in your own home lab, or are wanting to do this on your business network, you'll have a little bit of a guide on how to do it. Before we jump in, I want to do a little bit of housekeeping and remind you that if you enjoy the content of the video, make sure you click like and also subscribe to the channel. When you subscribe to the channel, click the bell so you get notifications on when new content comes out. And lastly, make sure you leave comments on the video. As with most things in IT, there is no one way to do something, so I always welcome comments about possibly different ways of doing the same thing of whatever the concept is of a video, or if there's a better way to do it. You know, I'm here to learn just as much as everyone else in the community, so comments are a great way to be able to share that information. Also, if there are particular topics that you would like me to cover, either IT related, or if you watch my music oriented videos, make sure you leave comments about that as well, so I can produce content that would be useful for you yourself. So let's jump in. Today's project is going to be about building a local DNS server, and the reason why I'm wanting to do this is twofold. One, for just general name resolution on my home network. I'd like to have my own name server for that, mainly because you could potentially get a little bit faster answer to queries by having a server on your LAN that's caching name servers. The other part of it is just kind of the geek factor of, hey, I have my own DNS server. The other part of the goal is for the lab itself. I'll eventually have several VMs and such deployed that I want to reference by name, and the internet at large is not going to know about what's in my lab, and so I want to be able to have that name resolution. So I would be configuring the DNS server to respond to queries for like edgerouter1.ejslab.com. You know, it would be able to return the IP address for that. For this video, what I'm going to be focusing on is just the initial installation of the bind application, which stands for Berkeley Internet Name Domain. It's also known as the named server. It's a very common DNS server that you'll find in Linux environments. And I'll be going over the difference between caching and forwarding servers. And once we have this configured, the first goal of just having general name resolution will be done. In a separate video, I'm going to go over what an authoritative DNS server is and get into configuring DNS zones, which that's going to satisfy the requirement of, for the particular devices in my lab, have DNS available to where they can be referenced by name. So at this point, we're going to head to the terminal and a VM and demonstrate how to configure bind and show what you can do to test your configuration and make sure everything's working properly. So here we are in the lab environment. We're going to be working with two VMs here. One is NS Demo. This is running CentOS 8, and this will be where we are installing the bind service. And we also have a NS-Demo client. This is a VM running Fedora 31 that we're going to use to test to make sure that we truly do have some DNS resolution capabilities on our network. So here we are with the NS Demo. This is a fresh install of CentOS 8. The only configuration I've done was running DNF update. Just you typically want to do that on a fresh install and make sure everything's up to date. This is also using the minimal installer. So during that installation mode, I chose the server minimal, mainly because all we want on this is DNS. I've also it has a static IP address, and I've set its DNS server to use, I've set DNS to use the Comcast DNS servers, which I think is like 75.75.75.75. Eventually, we'll be using a different DNS server. and I'll show you that when we get to it. So the first thing we need to do is install the packages that we want for bind. There are several little things with bind, but there are two that you need to really get you started. So the first thing I'm going to do is use sudo, and if I can spell that, -i. What this will do is log me in as root. Now, I don't have to do this. If I wanted to pretty much do every command preceded by sudo, you can do that. Otherwise, you simply run temporarily as root to do what you need to do. So to install bind, I'm going to do dnf install bind and bind-utils. It's going to prompt me. You can do the -y to avoid that prompt. And in just a few seconds or so here, everything will be installed, and we'll have what we need to be able to have a functioning DNS server on CentOS. Now you can do these steps on other distributions of Linux as well. There may be a couple of little changes that you have to do, but the general concepts will work with pretty much any distribution. So right now, if I were to do systemctl, since this is a systemd system, status and named, which is the name of the DNS server, we're going to see that it exists, but it is currently inactive because it's obviously not running and we haven't configured it yet. Also, if I were to use the ss command and tulpn, those of you that have used netstat will recognize tulpn. If you're new to it, I encourage you to check out the man pages to know what each of those little flags does. If I do that, we're going to find that there is currently nothing listening on port 53 for anything. So I'm going to move into the etc directory, because in the etc directory we will find named.conf. And this is the main configuration file for named. There are a couple other files that we'll be working with in the var directory tree. That'll be in the next video when I talk about doing zones and configuring an authoritative server. But remember, for this video, what we're wanting to do is have something that will generally answer DNS requests. And those types of servers that do that are known as caching servers, and they, when you send a DNS query to them, so your client machine, you want to go to google.com, that will go to your DNS server, is probably a caching server, and it's going to say, hey, I don't know what this is, let's talk to the root DNS servers, and there will be a series of queries that will end with an authoritative answer being sent to your DNS server, and then that answer to what's google.com, whatever IP address that is, that'll be sent to your client machine, and then you'll be able to access google.com. I'm not going to go into a lot of detail of those different types of servers. I might do that on another video, but just understand that the caching server is going to be answering questions for DNS, and usually doing that by talking to your root DNS servers, and there's, I think, 13 of them throughout the world. We're going to be doing something a little different with this lab. In addition to this being a caching server, we're going to make it be a forwarding server as well. And so rather than this particular server talking to the root domain servers, I'm going to configure it to forward these requests to another server that will do the heavy lifting. And there's a couple of reasons for doing this. One, even though this would be probably a minuscule amount of traffic coming from my network, it will save a little bit of resources on the actual root servers, because otherwise this is yet another DNS server out on the internet that's querying the root servers with recursive queries to answer questions. The other thing is the next server up that you would configure forwarding probably has some caching already on it, and you will likely get an answer to your query faster than going to the root servers. It's perfectly acceptable to have this querying the root servers from a technical perspective. There's nothing stopping you from it, but just it's my preference to send these requests to another server such as Google's DNS servers, which is what we're going to do. So they will do the heavy lifting of doing the iterative queries, or the recursive queries, rather than my DNS server having to do that. So to get into the configuration, we need to edit this named.conf file. I'm going to use the VI text editor. Some folks like Nano, others like, I think, Emacs is another. I tend to use VI. Some people hate it because they think VI is difficult to use. When you learn how to use it, it's not that bad. So I'm going to do VI named.conf. And this is going to have several configuration options and such. We're only going to be touching a few of these. In particular, we're going to be dealing with the listen on port, because we want port 53 to be listening in such a way that requests outside of just our local host will be able to answer. We're going to be configuring how to control what's able to query this server. By default, recursion is on, and we want this to happen. If recursion is off, then this server is not going to try to either talk to a forwarder or talk to a root DNS server to answer questions. You can read the comment there, and it talks about if you're making an authoritative DNS server, you would not want to enable recursion, because the sole job of the authoritative DNS server is to answer the questions, not to say, hey, I'm not sure about this, let me forward you to somebody else. That's the job of the caching servers. There are other configurations that you can work with as well. It also has a particular zone, and this is the root domain, just the dot. And so by default, we know, and there's a file named.ca that's going to have what the root servers and such are. We're not going to touch this. This is here by default, which is why recursion being on by default, it knows it can talk to the root DNS servers. So going back to the top, first thing we're going to work with is what we allow to query the server. And what we're going to do, I'm going to press I to go into insert mode for VI, and we're going to create an access control list. Simply type ACL. We're going to name our access list. I'm going to call it allow query. We're going to do an open bracket. And what I'm going to list here are the things that I want to be able to query this DNS server for answers. First, I'm going to include the network that my home lab is on. I'm doing /24 because I want to include the entire subnet. I'm not just saying individual machines are able to query. You could if you wanted to. We'll end that with a semicolon. These semicolons are important. In your endeavors with bind, if you find stuff's not working, odds are it's because there is a missing semicolon. We're also going to include localhost in this. I'll explain why in just a moment. And local nets. This represents the individual network interfaces that you might have multiple interfaces on this server, and you would want to include them. I don't believe it's 100% required to do, but I tend to do that in my access control list. We'll close the bracket and add the semicolon. Again, if something's broke with named, check your semicolons first. So what we're going to do now is go to allow query, and we're going to change this value from localhost to our access control list. So when named reads this configuration file, it's going to read that access control list and then allow queries from things that are on it. That's one of the reasons why I included localhost on it, so that way we just have the one thing to configure as far as what we allow queries on. I already mentioned that recursion is already on. Recursion, yes. We're also going to add a statement called forwarders. And this is what I was saying, where we're going to tell this DNS server that, hey, yes, you're answering questions, but first you're going to talk to another DNS server that's upstream, this server you're forwarding to, rather than going directly to the root name servers to go through the process of finding the answer. So just like with the access control list, we'll make an open bracket. I'm going to give it an IP address This is Google's server. If I wanted to, I could add another IP address and add a semicolon, so I could include Comcast servers. But we're just going to have the one forwarder. We'll close the bracket and add a semicolon. We're going to add one more statement, and that statement is forward only. You technically don't necessarily need that, but for right now, what I'm wanting to do is make 100% sure that this DNS server is only going to forward requests and only forward them to this particular IP address. And as far as this configuration is pretty much done. So one of the jokes about VI is it takes longer to get out of VI and save your file than it does to make the edits. There are multiple ways of doing that. I'm going to press the escape key, and I like using :X because that's going to exit the file as well as write the file. So to start named, I'm going to combine two steps. I'm both going to start the service and enable it. Enabling allows the service to start automatically when you reboot your server. So I'll do systemctl enable named, and I'm going to give it the -- now option, which is both going to start it and enable it. And now we can do systemctl status named, and we see that the service is running, and it gives you a little bit of the log file information from your journal CTL with that. Press Q to get out of that. So let's check SSTULPN, and we see that it is listening on port 53, but just on the local host address. Well, we want this to listen on its network interfaces as well. So I'm going to go back into named.conf, and we're going to change this listen on port from just the local host. I'm going to change it to local nets. So that'll get every network interface. Use the :X to get out of VI and save the file. We're going to restart named and SSTULPN again, and we now see that it's listening both on localhost as well as 192.168.1.250, which is, if I do IP-adder show, that is the IP address of this VM. So as far as DNS specific configuration, we are done. You have a functional DNS service. So let's go to our client and make sure that this is working. So I'm going to log in here. Now you can do this via command line if you wish. I'm going to use the GUI for it. So we'll go to settings and go to network. Now I have a static IP address already configured on this. I did that during setup. Now I'm going to add my DNS server. 250. We'll apply that. Now, in order for that to take effect, we're going to turn off and back on the NIC. And if I did not do that, even though we've added the DNS server address, there's a particular file. I'm going to open the terminal now with only one L. There's a particular file called etcresolve.conf. And this is what tells your machine what DNS servers to talk to. If we did not start and stop the NIC, then this will just show generated by Network Manager. It wouldn't have the name server. Now that it does, it knows to send DNS queries to 192.168.1.250. So let's put this to the test. Let's see if we can ping google.com. Lo and behold, name or service is not known. A common thing that you'll sometimes forget when working with a Linux server is configure the firewall. Kind of the beauty and savagery of that, by default, the firewall on a Linux server is pretty much going to allow SSH and DHCP. Other than that, it does not allow the traffic. Some people see that as an annoyance. I personally like it because that means that there's no special stuff being able to communicate to your server unless you explicitly tell it to do that. So we're going to go back to our name server here, ns-demo. We're going to do firewall-command. And since we're still on as the root user, we're not having to use sudo for this. Permanent, because this is going to be a DNS server. We want it always allowing traffic on port 53. Add service DNS. Now you could do add port and do TCP and UDP 53. I'm just doing the add service. And then another common thing that we'll sometimes forget to do, I myself included, is forget to reload the firewall. So at this point, the firewall has been configured to have DNS, and it has now applied this configuration. Let's try pinging google.com again, and lo and behold, we get name resolution. It was able to resolve the google.com address. Now, was not able to get echo replies. That should not be an issue, though. Let's try one more. There's our echo replies. Let's try Google again. A little surprised by that, but you can ping my personal site, which also redirects my business site, and we're getting the both the name resolution, which name resolution was working for google.com, and our echo replies as well. For just the DNS portion, which is the scope of the video, all is good here. One other thing that I want to address is the DNS server itself. And what I'm going to do is actually configure this to use itself for DNS rather than a different source, because right now it's going to be it's configured to talk to Comcast DNS servers. You don't have to do this. There may be instances where you want your DNS server to use a different server than itself for DNS query. But if you wanted to set it to resolve to itself, we're going to use the nmcli commands for that. And I know I'll just do nmcli connection. You can shorten that if you want. Con show, and the name of the connection on this server is ENS3. So I'll do nmcli con edit ENS3. And the setting that I'm first going to remove IPv4.DNS, because I don't want the current setting that's there to remain. So now we'll do set IPv4.DNS. We're going to set this to localhost. And then we'll save, we'll exit, quit rather than exit. Now, just like on the client machine, we need to restart the network. I'm not just going to take the interface down and up because this is an SSH session to it. So instead, I'm going to do systemctl restart network with capitalization manager .service. All right, and now if I were to cat that etc resolve.conf, we see it's using our name server. So now let's see if we can ping eddiejennings.net from this. And lo and behold, we get name resolution and we get ping. Just for giggles, let's see if, yep. So for some reason, google.com, even though it's kind of an odd IP address, I was not expecting one from the 74 network. But for our basic DNS resolution, we have that. So as proof positive, let's go back to our client machine, run a web browser. We have Firefox here. And let's see if we can go to be a little odd here. Yep, Firefox privacy notice. Let's try google.com. And there's google.com. And let's do another one, a little shameless plug here, ejsllc.com. Yep, and we have name resolution. So at this point, you have a functioning DNS server that is going to have the service running at time of reboot because we have enabled the service. We have configured it to forward queries to another DNS server, and we have also configured the firewall on the DNS server to allow traffic on port 53 to be able to allow to allow the traffic to come in for the queries. I hope that you found this video useful for you. As I mentioned earlier, make sure you click like and subscribe to the channel as well, and feel free to leave comments with suggestions on different ways of configuring this, or with questions about how to do it. And I look forward to seeing the feedback and responding when I can. Thanks so much for taking the time to watch, and I'll see you the next time.